Alright, we're going to look at rectangles, squares, and rhombi as we continue our little adventure through quadrilaterals. So again, these are all four-sided figures. We're going to go through quite a few properties today about each one. Some that you're probably pretty self-explanatory to you guys, but we want to make sure we know the ins and outs of all three shapes. So a little parallelogram review, because since these are all going to be parallelograms, we want to know what's going to be true about these, plus a couple extra things. So we know opposite sides are congruent. We know opposite angles are congruent. We also know opposite sides are parallel. You can see if you want to work ahead, maybe figure out the next couple. Consecutive angles are supplementary, and diagonals bisect each other. So what we're going to see here is we're going to look at a rectangle, we're going to look at a square and a rhombus, and say, okay, here's a couple of more properties, but all five of these things are going to be true for all three of these shapes because they fall under that category. So basically, we have these three things are all parallelograms. So the first one I want to look at is a rectangle. A rectangle is a parallelogram because it has all those things with four right angles. Okay, that's all we know. Four right angles, that's a rectangle. By this definition, we can say that a rectangle has opposite angles congruent. Because of this, we can say that every rectangle is a parallelogram. If a rectangle is a parallelogram, then it has every property of a parallelogram. So meaning all five of those things are true. Plus these couple things. We know that the diagonals of a rectangle are congruent. And I'll show you what that looks like in a second. And that rectangles have four right angles. Okay, so if we draw a little rectangle and label everything we know, including maybe a diagonal in there, and we'll call it A, B, C, D. We're going to go one at a time. So up at top, opposite sides are congruent, opposite angles are congruent. So I'm going to mark that first. Opposite sides congruent, opposite angles are, actually I guess I should mark those all the same. Would make more sense since they're all 90. Okay, so we know that. And with that, I'm going to mark this as a right angle like I should have at the beginning. So we know that. We know opposite sides are parallel. And we can go ahead and mark that. We know that consecutive angles are supplementary. That's kind of hard to mark, but you know that those 90 plus 90 is going to be 180. And diagonals bisect each other. So let me draw another diagonal in here. It's a pretty bad one, but it'll work. So I'll use, let's see, something different, maybe a different color. I'm going to say that, and I don't want to use 4, so I'm going to use a circle and a circle. You can do that. You always feel free to mark those as long as you're showing that they're congruent. So they bisect each other. That's the 5 from a normal parallelogram. Now the two new ones, we know that the diagonals are going to be congruent. Okay, kind of hard to mark. And then we already said that they have 4 right angles. So we should actually change this now based on this one and say that, okay, these are actually all going to be the same and they bisect each other. So we can mark it as this. Okay, that's what a rectangle is going to look like. And we'll look at some examples. Next one is a rhombus. It's a parallelogram with 4 congruent sides. Okay, so we have 4 congruent angles. That's a rectangle where they're all 490. 4 congruent sides here. These angles are not 90 degrees. Thus, a rhombus has opposite sides congruent and is also a parallelogram. Remember, this means that all of the parallelograms properties are still true, but some things are also now true. So a couple of new things. Okay, so the first thing we know is, oops, before I see that, I meant to say rhombus is a quadrilateral. That makes a little bit more sense. A four-sided figure with four congruent sides. And did I do that in the one before? Yes, I did. A quadrilateral, and again, see, this is why we always write in pencil. Okay, so that makes a little bit more sense. So as we were looking at this, we know that the sides of a rhombus are all congruent. It does not make it a square because we don't have right angles. We know that each diagonal is an angle bisector. And I guess I meant to say that all sides of a rhombus are congruent here, and I wanted to fill in up here that the diagonals of a rhombus are perpendicular. Sorry about that, I'm off my game today. So draw rhombus ABCD and mark everything we know. Okay, so we have some diagonals in here, and we know a bunch of different things. First of all, again, thinking back to the ones at the top, if you need to scroll back at each time, that's fine. But we have opposite sides congruent, opposite angles congruent, opposite sides parallel, consecutive angles supplementary, diagonals bisect each other. A whole lot going on. So, we also know now that the diagonals of a rhombus are perpendicular. So we know that. Each diagonal is an angle bisector. So we know this. And all sides of a rhombus are congruent. So we know this. Okay, so anything not there from the new stuff is going to be in the old stuff. Okay, well, scrolling back up. We know that diagonals bisect each other. So we know this. We also know anything else we missed. Let's see. Consecutive angles are supplementary, hard to label. Opposite sides parallel. Already got. I guess we can mark that. And then opposite sides are already congruent. Opposite angles are already congruent. So those are all the new things. So really, a rhombus is kind of a square that's been pulled on the top one way, on the bottom the opposite way to create this rhombus figure. Last one, the one you guys I know you've been waiting for. A square. Pretty simple idea. Basically, what a square is a rhombus and a rectangle combined into one thing. So, a quadrilateral with four right angles and four congruent sides. We all know what a square looks like. This means that a square has all the properties of rectangle, rhombus, and parallelogram. So basically they're all rolled into one. So here they are. A square has four right angles. A square has all sides congruent. A square's diagonals are congruent. You can write it out or a shortcut. A square's diagonals bisect each other. A square's diagonals are perpendicular. And last but not least, a square's diagonals are angle bisectors. So lots of responsibilities in a square. So let's draw one of those and then apply some of these traits to some of these problems. So we have A, B, C, D, diagonal, diagonal. Mark everything we know. So we know this. All sides are congruent. We know we have right angles. We know we have sides that are parallel. We know, we know we have right angles there, perpendicular. We know that all these segments are congruent because they bisect each other. We know that our, what else do we know? I guess there might be everything I can mark. See if I've got everything. 4 right angles, all sides are congruent, squares diagonals are congruent to each other, squares diagonals bisect each other, got that. They're perpendicular and angle bisector. So we've got everything covered. Angle bisector is the only one that you might want to be careful about. Basically, if they're 90 and it's being cut in half, they're all 45. It's kind of hard to mark. If you wanted to write in that we have 45 everywhere, that might be useful later on. We've talked about that before in Unit 5, so we know that's being cut in half there. Finally, some examples. So this is probably going to be the easier part now that you guys have all that stuff done. Use rectangle ABCD to solve each problem. So measure angle 1 is 70 degrees. Find 2. And then AE is 10. Find B. So let's start with A. If 1 is 70 degrees, okay, we're trying to find angle 2. So we're not really focused on anything but that kind of triangle part on the left side. If we know that that angle is 70 degrees, we know that these should be the same, okay, because it's a rectangle. We know that these angles are 90 degrees, and then you have the diagonal that's kind of cutting it up. So we know those have to be the same. So if this is 70, we're going to take 180 minus 70 equals 110. Cut it in half, that makes this 55 degrees, this 55 degrees. Now, kind of erase, start over. If AE is 10, so AE is 10 right here, we want to know what BD is. So what's this here? Well, if AE is 10, we know that this is 10, which means this is 10 and this is 10. Because the rectangles, diagonals are congruent to each other. You can check back up and see that, which means BD is going to be 20 units. Find the value of x and y in TSRV. So VW, 2x plus y, WS, 36, RS, so this whole thing is going to be a little bit different to mark. I'm going to mark that out here, x minus y, and oops, no wonder that looks weird. We're going to get to problems like that where you have that whole thing marked, but not yet. RS is over here. I don't know what I was looking at. X minus y, and VT is 9. Okay. Based on what you know about a rectangle, let's set up some equations. So we know that this is true. We also know that this is bisected here. So we have one equation that's going to say x minus y equals 36. We're going to have another equation. Just kidding. X minus y equals 9. Holy cow, am I off my game. X minus y equals 9. 2x plus y equals 36. Again, recognizing the system from the beginning makes it a little bit easier. That cancels. That works out very nicely. 3x equals 45. So x is going to be 15. X minus y equals 9. So we have 15 minus y equals 9. So y is going to be 6. So there would be x and y. A little system. Again, just making sure you know all your properties in here. Last one, I'm probably going to save C for you guys for tomorrow. But use rhombus bear and the given information to solve each problem. So we have BR is x squared. BE is 9x minus 14. Find the perimeter of bear. Because we want to know what what everything is going around. Now, if you look back up at your rhombus information, you know that a rhombus has a bunch of congruent sides. It's not a square because they're not 90-degree angles, but a bunch of sides are the same. So what we could say is x squared equals 9x minus 14. If we can get one side, we know all four sides. Subtract 9x. I'll add 14 at the same time. So we get x squared minus 9x plus 14 equals 0. It's a box problem. Give you a couple seconds to try and think of what might work or set up your box. We'll see if you're right. You guys are probably already pretty good at this. So we have -7, -2. So that means we have x equals 2, x equals 7. Two very possible answers. Let's see if both of these work. Well, if I plug in 2, I'm going to get 4 here. And I'll get up here, what's 2 times 9? That's 18 minus 14, that's 4. So if x is 2, the perimeter is going to be 4 times 4, or 16 units. That works. If x is 7, I'm going to have 7 squared is 49. And up on top, I'm going to get 49 as well, or 49 times 4, which is going to give us 196 units. So very different possibilities, but both are possible. You can use x equals 2 or 7. You need to have both there. Kind of erase your thoughts from here. Start over, just to kind of give yourself a clean slate. We have 15x minus 15 for BSE. That's an angle, so this angle here, it's going to be congruent to that. We already know that from vertical angles, if we need to use it. And we want to solve for x. Well, we know, okay, going back, if we look at our rhombus properties again, that this is actually a right angle here, here, and there. In other words, boom, 15x minus 15 equals 90. I'll let you guys solve for that, find out what x is. Then the last one I'd like you guys to try as well before you get to class tomorrow. So make sure everything's marked. Use your rhombus properties from above if you need to. See ya.